I made a map projection tier list. I actually expected this to be something numerous geography YouTubers have done already, but when I looked it up a while ago, apparently only Emperor Tiger Star has done one. Link to that video in the description. So, this will be the second map projection tier list on YouTube. Unlike Emperor Tiger Star though, who appears to have rated maps nearly entirely based on aesthetics, I will factor in the aesthetics, the formulation, and the applicability of the projection, because the soundness of the idea and the usability of a projection for various purposes should matter as well, I would posit. Before we dive into how I ranked 35 different map projections, which I'll go over in chronological order of publication, I should note that when I do tier lists, I don't use S tiers. I don't like S tiers because the alphabetical consecutiveness of the tiers is supposed to neatly reflect the order of the ranking, and S breaks that pattern. When I make tier lists, by default I use 16 tiers, A, B, C, D, E, and F, with plus and minus for each non-F letter, so A+ is the best possible tier. Though for specifically the map projection tier list, I will also be giving no projection in A+ to reflect that every attempt at projecting a 3-dimensional sphere onto a 2-dimensional surface loses something. A is the highest tier in which I'll place a projection. We will start off with the equirectangular projection. We begin with this projection with an extremely simple definition, where the axes are simply latitude and longitude, and the distance along each axis is simply proportional to the amount of latitude or longitudes traversed. In this projection, if place A is to the right of place B, then place A is genuinely to the east of place B, and ditto for up and north, left and west, and down and south. Of course, since the Earth is a sphere, this means the further from the equator one goes on the map, the further a general area is stretched east-west from its actual size. At the extreme, the poles, which are single points, are stretched to an entire boundary spanning as far as the whole equator, which is a drawback. But overall, how decent this projection looks for its simplicity, along with how simple it is to calculate geographic quantities with this projection, makes me deem the equirectangular projection A tier. Next, the Azimuthal Equidistant projection. First off, tangential personal experience fun fact. In one of the dictionaries I had growing up, Azimuthal Equidistant projection was the longest defined term in that dictionary, by total letters when including spaces. And tangent. This projection is neat and is a great complement to typical projections in reminding people of the Earth's spherical nature, grouping Arctic areas close that people often don't see together in other map projections. You could also have an azimuthal equidistant projection from any point on Earth. It's just that it's the most useful viewed from a pole, and people tend to do things with the Arctic more frequently than the Antarctic. So for people, the Antarctic is the better pole to greatly distort. Standing alone, though, this projection is somewhat suboptimal in applicability. What's good about it is that from the center point, every other point is at the correct relative distance and in the correct relative direction. When a pole is the center point, places on the same longitude are on the same line, and places on the same latitude are on the same pole-centered circle. But they're serious quantities of uncomfortable stretching. B+ tier. Next, the Stab-Werner projection. This is the first projection we're covering in which both poles are one point on the projection in reflection of real life. Every circle of the same radius on the Stab-Werner encompasses the same amount of real-life area. In this projection, this comes at the pretty large cost of no horizontal line reflecting a latitude line, and only one vertical line reflecting a longitude line, as well as severe distortion along the edges. B- tier. Next, the Ortelius Oval projection. This is our first compromise projection, in that rather than trying to be perfect on one desired aspect of a projection, it is a small amount bad on many factors. It looks somewhat decent. B tier. Next, the Mercator projection. Most people know about this one, the one where Greenland looks as large as South America despite having less than 1/8 the size. In the Mercator, like in the equirectangular, up is always north, right is always east, etc. And going beyond the equirectangular, now if you take any angle, not just orthogonal ones, like 60 degrees inclined from the equator, if you continue on a straight line on that projection, you are continuing at an angle of 60 degrees inclined in real life. That's very helpful for orientation and really easy to code with. But with projections, our question is always, but at what cost? And with the Mercator, well, many people do not realize this, but none of you have ever seen the full Mercator projection. Every Mercator map cuts off the projection at some point before the poles, because the way the Mercator is defined, the poles are at infinity. Yeah, the Mercator technically requires infinite space to display. That's how bad the polar distortion is. B tier. Next, the sinusoidal projection. I like the relative mathematical purity of this projection. Like with the Stab-Werner, each circle of the same radius on this projection contains the same area. It is awfully ugly though. Only a small fraction of the map looks okay. I feel this is one of those projections for which for nearly any purpose there is a different projection that I would rather use. C+ tier. Next, the Cassini projection. Like the Azimuthal Equidistant, the Cassini is one of those projections that complement other projections in reminding people of the Earth's spherical nature, and this time you get to center both poles. Everything else, though, is even worse. Now you don't even get the benefit that places with the same longitude are on the same line, or that places with the same latitude are on the same circle. You could glue the ends of the Cassini projection together to make a nice torus, but hey, remember, we're talking about how to optimally represent a sphere in 2 dimensions. So that's outside our considered possibility space. C tier. Next, the Mollweide projection. I strongly respect the Mollweide, and it is tied with another projection I'll talk about later for best projection in my view. Every circle of the same radius on the Mollweide corresponds with the same amount of area in real life. Left is always west and right is always east, and the map looks staggeringly decent for being faithful to the poles being a single point. Of course, near the poles and near 180-degree longitude, things still look rather distorted. The goal in projection is to make the inevitably bad parts the least bad, and the Mollweide has an impressively small amount of bad. A tier. Next, the Gauss-Krüger projection. At every point in the map in the Gauss-Krüger, 2 directions n degrees apart in real life are also n degrees separated at that point, and unlike the Mercator, which also does this, the Gauss-Krüger only requires a finite space to display in full. Though when you look at it or try to use it for any purpose where angle preservation is not the main concern, was this worth it? B- tier. Next, the rectangular polyconic projection. Neat idea, but I'm not really that convinced by a projection that maintains the straightness of only the equator and prime meridian, substantially distorts anywhere even a bit far from the prime meridian, and doesn't even preserve either areas or angles to show for it. C+ tier. Next, the Gall projection. Well, it is less distorted than the Mercator, and can be displayed in full in the finite space, but it doesn't achieve any neat preservations beyond up, right, down, and left always being north, east, south, and west. B tier. Next, the Gall-Peters projection. Alright, so this projection looks like a meme, right? This map attempts to go for circles of the same radius containing the same real-life area, while maintaining that up, right, down, and left are always north, east, south, and west. And it turns out, if you try to achieve both of those, you get this monstrosity. And you know this map is lacking, because Peters tried to advertise this projection with claims like that it's distance factual, which is observably false. I'd normally give substantial consideration for good formulation, but it's really hard to give much for this projection, and thus I'm giving it C tier. Next, the Collignon projection. Oh looky, a triangle! Ooh. I think this is the second projection today where the number of poles accurately displayed as 1 point is an odd number. Like the Gall-Peters, every circle on this map contains the same amount of real-life area, so the Collignon kinda displays the Gall-Peters' derpiness one-directionally. And now the equator is a different distance from the 2 poles on the map. Suboptimal. C tier. Next, the Peirce Quincuncial. Okay, so like in the Mercator and in the Gauss-Krüger, 2 directions separated by an angle in real life are separated by the same angle on the map at any given point. Except I would argue that unlike the Mercator and the Gauss-Krüger, the Peirce Quincuncial looks good. Though with the Earth, that is partially due to where the continents happen to be located. If the Earth had a continent halfway between South America and Africa, for instance, that continent would be cut part way down the middle and look really ugly. You know what I like to do with the Peirce Quincuncial? It can tessellate, so let's just copy over half of the world onto the right edge, and the bottom edge too, and then complete the square. Ah, now we get to see a complete Antarctica too. The Peirce Quincuncial gets B+ tier in my view. Next, the Hamea projection. So here we see the technique of slightly bending the latitude lines as you approach the poles to make the shapes of figures near the 180-degree longitude less screwy. You see this, Gall-Peters? This is how you preserve area and keep a map looking decent. Though of course, Mollweide does it even better in my opinion. Well, not the making shapes look better, the preserving it while preserving west and east. Shape-wise, the Hamea is better. A- tier. Next, the van der Grinten projection. This projection is just downright terrible. Imagine if you took the Mercator and then took away the redeeming qualities of the Mercator. You no longer preserve angles, you no longer preserve up, right, down, and left being north, east, south, and west everywhere, and in exchange you get Greenland looking just slightly smaller than South America? Not to mention, the van der Grinten is mathematically substantially more complex than the Mercator in its formulation. Can you believe that once upon a time, this projection was National Geographic's projection of choice? What were they smoking? And also, what was van der Grinten smoking? I assert that he should feel bad for coming up with this. E tier. Next, the Eckert II projection. A hexagon. Every circle of the same radius in the Eckert II contains the same amount of real-life area. Within the northern or southern hemisphere, both latitude and longitude lines stay as straight lines. Unfortunately, around the equator, things look really bad. I mean, look at the northern Indonesian islands. Other than that though, not bad. B+ tier. Next, the Craig Retroazimuthal projection. What this projection does is it takes one point on Earth, and for every other point on Earth, the direction that the origin point is from the other point on the map reflects the direction of the shortest distance to that origin point in real life. That's what retroazimuthal means. Consequently, the antipode of the origin point is at infinity. The original instance of this projection had the origin point at Makkah to help Muslims know which direction in which to precisely accurately pray. Anyway, the Craig Retroazimuthal is good at this one niche thing for one point on a sphere. For pretty much any other purpose, good luck using this projection for that. E+ tier. Next, the Hamea Retroazimuthal projection. I think my comments are the same as for the Craig Retroazimuthal. I do aesthetically dislike this slightly less. D- tier. Next, the Winkel Tripel projection. I'm a big fan of this one. It uses the slightly bending the lines of latitude technique to make everywhere look somewhat decent. I find myself desiring that it does more for the sacrifice of left and right being west and east though. A- tier. Oh, tangential note. It's very common to misspell Winkel Tripel as having a hyphen between Winkel and Tripel. Here's the lore behind the Winkel Tripel hyphen. In Deutsch, that is German, you would put hyphens in compound names, so it would be called the Winkel Tripel Projektion. So when translating over to English, one could mistakenly think the hyphen is part of the name. But like how Johannes Brahms Strasse would translate to Johannes Brahms Street in English with no hyphens, Winkel Tripel projection is not supposed to have hyphens either. Next, the Goode Homolosine. I generally really like the Goode Homolosine and think it has a really creative solution to the problem where parts close to the 180-degree longitude are badly distorted in most projections that keep the poles compact. But it is defined piecewise, with areas lower than 45-degree latitude formulated differently than areas higher than 45-degree latitude. This affront to simplicity makes me knock the Goode Homolosine down to B+ tier. Next, the Boggs Eumorphic projection. Or as I like to call it, the better Homolosine. It makes nearly everywhere look decent, just like the Goode Homolosine, but this time the formulation is a cohesive idea for all of Earth, even though it's mathematically slightly complex. A tier. Next, the Wagner VI projection. Not bad at all. Everything looks rather natural. It's a simple yet effective formulation. My only complaint is that I think by trying to make squares square along the equator, the map is too long. A- tier. Next, the Loximuthal projection. Not bad. This projection, like the Mercator, keeps angular directions consistent, but for just one point. Though in exchange for doing this for only one point, the map looks a lot more decent than the Mercator. B+ tier. Next, the Kavrajskij VII projection. This projection, along with the Mollweide, are tied for my favorite projection. Look at how decent everywhere looks on the Kavrajskij. And despite how aesthetically fine the Kavrajskij is, it still maintains left and right being west and east everywhere, unlike the Winkel Tripel, and has a mathematically simple formulation, unlike the Robinson. Unfortunately, the poles are not 1 point on the Kavrajskij, but you've always got to lose something in projections. Barely anyone uses the Kavrajskij. I want to see more Kavrajskijs around the world. A tier for this beauty. Next, the Dymaxion. Okay, so I really like this creative solution to making all landmasses look undistorted within themselves, but I have to say that the cuts could use less arbitrarity for simpler definition. I also want to point out that on the Dymaxion, it's technically not the case that circles of the same radius contain the same real-life area. It's just very close, like how an icosahedron is a very close approximation to a sphere. It still has a lot going for it. It has enough faults for me to think it does not deserve a pure A tier, but I'll put it in A- tier and say it's the best in the A- tier. Next, the Sinu-Mollweide projection. I think this combination of sinusoidal and Mollweide projections is quite bad at keeping the good parts of both of them. Every circle of the same radius contains the same real-life area, but both the sinusoidal and Mollweide projections already have that and do it much better. C+ tier. Next, the Robinson projection. Now here is an Earth that looks really good. But at what cost? At the cost that the Robinson's mathematical formulation is insanely complex, filled with magic numbers beyond that of any other projection. If you're trying to compute something with a map, the Robinson is the last projection you want to work with. Because of this, I knocked the Robinson down to B tier, which is appropriate because then it lands in the same bucket as the Mercator, and they are complements to each other. The Mercator is mathematically pristine and aesthetically atrocious, and the Robinson is aesthetically pristine and mathematically atrocious. Next, the Cahill-Keyes projection. I'm not very convinced by this. When you cut up a map this amount, I expect some very good results, and this projection doesn't deliver anything particularly stunning. C+ tier. Next, the Waterman Butterfly. So I do think this is a better adaptation of the Cahill concept. The equator at least turns consistently in one direction. I think it's still not enough though. I do want to note that the Wikimedia images show Antarctica separately treated in the Cahill-Keyes and Antarctica not separately treated in the Waterman Butterfly, but in either choice, either treatment of Antarctica has been used. B- tier. Next, HEALPix. My complaints about sharp turns I mentioned when talking about the Eckert II apply here. Otherwise, this is a good Homolosine-like choice to use cuts to make polar areas look somewhat decent, while maintaining circles of the same radius containing the same real-life area. Good? This map is relatively easy to compute with. Bad? The polar areas don't exactly look as great as one would like. B tier. Next, the Hobo-Dyer projection. The makers of the Hobo-Dyer said that they wanted to make a map like Gall-Peters, but better looking. Well, does this look better to you? Because it sure doesn't to me. Also, if you're wondering if someone's surname was Hobo, no, the name of this projection comes from two of its makers' given names, Howard and Bob, and the third maker's surname, Dyer. Who does that? C tier. We're on the home stretch now. We've got the Bottomley projection. So this is like Stab-Werner, but not twisted enough such that sometimes you go down to go north. It's not amazing, but it's not bad either. B tier. Then we have Natural Earth. This is like Robinson in that it is made to be very aesthetically excellent, but its formulation has way too many magic numbers. B- tier. And finally, Equal Earth. This is like Natural Earth, except it's slightly modified to fulfill every circle of the same radius covering the same real-life area. It's quite good, but the concept has been done better. B tier. So that's the tier list. I crown Mollweide, Kavrajskij, Equirectangular, and Boggs Eumorphic as the A tier projections, with Dymaxion barely missing the A tier. What do you think? What are your favorite projections? I'd love to know. and I hope that all of you remember to love the night.